What we did yesterday, we have that, and then we have some other stuff that I'm going to give you here in a second. Some more of that inverse stuff, as well as the how we did the combination functions. We'll have some of those. You guys figured out real quick that if I take the tangent of the arc sine of root 2 over 2, it was pretty easy to do that. So yeah, you guys figured that out pretty quick. So I was happy with that. As far as these were concerned, the review ones you only had the 2-page stuff. What's still driving you batty on the first page?
3 through 6.
What do you got,
Number 10, finding the trigonometry functions.
Number 10, cosine of negative 630. All right, so what we have to do is first of all find the reference angle. It's negative, so I spin the other direction. So here's 360, 540.
That's right there. It's like right on it.
What is it, 540, and then what am I left with? 90?
You're at exactly 630.
Is it 90?
Yeah.
Oh, that's what I thought. So at that, well, the reference angle is, well, pi over 2, so it's the ordered pair is 0 and 1. What's the cosine?
0.
There. 0. Go to the next problem. All right? Yes, ma'am. I'm not on the back page yet. You should be sorry. I'm joking. Maybe. I promise, I'll get there. What else on the front, though? Then we'll flip. Mr. Cole.
Number 3.
Negative 11 pi over 6, and we want to find a coterminal between 0 and 2 pi. Negative 11 pi over 6, if you just place it, it's first quadrant. It doesn't go a full circle. Okay? So that means it's within plus or minus 1 revolution. So to this problem, since it's just negative, all I have to do is subtract 2 pi, add 2 pi. All right? Just like I would if it was within 1 revolution positive. So if I subtract 2 pi, to go around again, I'd be more negative. So I'd subtract 12 pi over 6, and I get negative 23 pi over 6. And then if I take the 11 pi over 6 and I add 2 pi, I get pi over 6.
I'm just struggling where 11 pi over 6 goes. Like, when you spin it. I know it's on there, but still.
Oh, you said find one coterminal. Okay. I'm going to ask you a positive negative. What happens is when you have 11 pi over 6, is that it's not full 2. Okay. So if you think about it, I'm going to go positive just because it might be easier to see. This would be 6 pi over 6, 1 pi. And then this would be 9 pi over 6, 1.5 pi. 12 pi over 6 would be all the way up, so it's off.
Oh, okay.
Okay? That's the idea. You're trying to break it into easier chunks.
Okay.
All right. Which number?
It lands on like 316. So it's here, so I was just
So I have that ordered pair. This is cosecant 2 pi. So if I land at that ordered pair, cosecant is the inverse of which trig function? Sine. So what's the inverse of 0? Undefined. It's undefined. Yes. Yes. I wanted to spend a little bit of time on these guys. Okay. How about, can I go back to those because I have some other problems that lead into that at the end, so I'll do those last, okay? What else you got in the, find the exact value? Exciting. It's a lot of spin. Yes, ma'am?
cosecant is opposite of
Sine. All right, so let's look at the last ones then. What is cosecant if sine is 24.25. So this means you have some angle, the sine of some angle is 24.25. Actually, let me draw this a little bit better. When we have these style problems, remember, theta is going to be placed at the origin. And the sine values are opposite over hypotenuse. Cosecant is the reciprocal of that. But what if I asked you for this? What would you have to solve for? Yeah, the other side, the adjacent side, correct. So if I solve for the adjacent side, I'm just going to use Pythagorean theorem. What's that? Yeah, it's what, 7? Okay. So now, cotangent's the inverse of which trig function? Tangent. Tangent's opposite over hypotenuse, or excuse me, opposite over adjacent, therefore cotangent is?
Okay.
So
That'd be great.
that was the answer.
Yes, sir.
So cosecant of sine of 24 is 25 over 24.
Yes, sir. You wouldn't even, in that case, you didn't have to even draw the triangle out. But I'm trying to remind you guys, because I have a couple examples here in a second, that you do need to draw it out to see where you're going. Okay. It's almost the same way of writing it like this. Let me do this. So if I have cosecant theta, it says find another way you could write this problem out is this. What angle has a sine of 24 over 25, and what's its cosecant? Remember, this means some angle, it's positive, so sine's going to go into the first quadrant. Some angle has a sine of 24 over 25. What's that angle's cosecant? See how that works the same way? The same way of writing it. It's the exact same way. It's just without using the word find and if. Screw you, find. Shake your fist at it.
Usually, are we gonna have to find the, wait, those are the reciprocal values?
Mhm.
Are we gonna, like,
No, no. And I talked about you guys weren't in 12th hour. In 12th hour, they asked, why don't we use the calculators to find out? Well, because it gets to be really, really messy. Real fast, and we're going to spend more time on this next week. Remember how I showed you guys the graph of sine
Yeah.
is broken down off the quadrantals? It doesn't go any higher than 1, doesn't go any lower than 1. So it starts at 0, goes to 1, 0, -1, and 0. And it does this. Okay. Now, when you think about your inverse functions, your reciprocal functions, cosecant is the inverse of sine. So at these 5 points, you can do the reciprocals. What's the reciprocal of 0? What's the inverse? It's undefined. So I have an asymptote here. I'm going to use a little dash so you can see it better. I have another one here. And I have another one here. And it goes back to the problem of 2 pi being undefined for cosecant. It's undefined because it lands the asymptote. Okay. What's the inverse of 1? Or I should say reciprocal of 1. 1. What's the reciprocal of -1? Now, think about the unit circle. Somewhere in the unit circle, you have sine value equal to 1/2. The sine value equal to 1/2 was at 30 degrees, wasn't it? 30 degrees is less than 90, so it was about 1/2 here. What's the reciprocal of 1/2? 2, which means, oops, I should probably make this lower. Which means somewhere up here at 2, that happens. Coming back down the other side, before I get to 180, I have 150 degrees. Bounces up into the second quadrant. It also has a sine of 1/2, which means it's up here. So cosecant, reciprocal properties, blows up the sine graph. It blows down the other part. So what happens is you are using the sine values, whatever the fractional amounts are, and you're flipping those fractions to get the cosecant. So if you have the sine value that's equal to √3/2, its cosecant would be 2√3/3. Does that make sense?
Yes.
You would solve a sine problem, for the sine of it, and then you would flip that answer. That's why we don't have a but. Does that clear that a little bit? It's hazy because you don't know how to do that yet. Once you know how to do that, it's like, oh yeah, that makes sense. I love graphic trig. It's so cool. It looks awesome when you do it right. And then we might do some shading in here and all that, make it look really cool. Anyway, let's try it. Let's look at 25. I'm going to write 25 differently. Means the same thing. I'm actually using terminology out of Freetalk for you guys, because you don't need to read this. You need to think about it in cool ways, like all the cool kids are doing. This means what angle has the secant of √13/3. Since it's positive, what quadrant should I drop into? No. Oh. I'm going to drop it to first quadrant. Okay? Secant is the inverse of what?
Cosine.
Cosine. So that means my adjacent would be, well, secant's going to be hypotenuse over adjacent. So my adjacent would be 3. This will be √13. What's my opposite then? 2. Wouldn't that be √13 squared? Oh yeah, it is 2. Sorry. Hi. For some reason I'm going, wait, 2 squared is, I thought I was doing 2 squared is 2. Wait, that's not right. Anyway, so what's the tangent? There we go. 2/3. Sorry. Brain fart. We've never had those in this classroom. Or at least I have never.
I had.
Well, yeah, I know that, but I wasn't going to say that.
Oh,
Okay? Not terrible? All right. Anything else on this one? Yeah, Will.
Can we have this on?
No, my friend.
What did he ask?
You don't need to know that. What do you need to know on there?
the first quadrant.
First 3.
Nope.
First.
All you need to know is what's the smallest angle on there. 30. Okay? If you know that's 30 degrees, what triangle is that? Well, it's a 30, 60, 90. What's the ratio?
2 and then 3 is 1.
So 2 goes where?
2 is the hypotenuse.
Okay. You know everything else then.
Sweet.
It's all you need to know. If you know that, then it's just a matter of it, okay, it mirrors, it mirrors, it mirrors, and it's back. That's it. You know everything off of that. You have to know the first angle. If you know the first angle, everything else applies. Yes, ma'am.
Cosine and like the order pairs, it's cosine and back.
Yes, ma'am. Because it's x, y. Just remember, it's the dumbest thing in the world to think of it that way because of the alphabet. Cosine comes before sine, x comes before y. Easiest way to remember it. Okay. Yeah, no.
And so for like ordered pairs that if it's like cosine 90 or
Same deal.
180 or something like that. that's
Same
what you
thing.
use for ordered pairs.
Yep, you use ordered pairs for everything. It just so happens that your ordered pairs are derived out of the triangle, out of the right triangle, the 36 and the 45.
Ordered pairs we wrote on the.
Correct. Whereas the ordered pairs on the quadrantal are just because you're going out one, you go up one, negative one, negative one, and your radius is always 1.
And so those ordered pairs, the first one gives you cosine, that means.
Yes, sir. Every time. Because what's 0 divided by 1? 0. Hence, cosine is 0. Okay. It's funny when it all starts to come together. It's exciting.
Is it really fun?
I love trig.
It ain't bad. Fun.
You can't,
Trig is a lot of fun. Actually, what's crazy right now is that in pre-calc, we started trig at the very tail end of first semester, and we still have 2 more chapters of trig to go. Yeah, you guys will. But in pre-calc, you get to do some cool trig.
What's cool trig?
Bearings.
What?
Bearings. Like ships at sea and airplanes. Yeah.
That's trig? Everything needs trig.
Yeah, that's trig. If you're in an airplane, if you're flying in an airplane at a bearing of 215 degrees. If you're in an airplane, you have a bearing of 250 degrees, that just means you always start at north and you go 215 degrees off north. So this would be 90, 180, 215, somewhere over here. You're going that direction. But that's pre-calc stuff. And then we do stuff like this where it's north 17 east. So you're coming off north to the east, whereas that's your angle there. Variance, and they just use SOHCAHTOA to solve stuff out. So it gets to be interesting.
Is this gonna have the inverse stuff on it?
Yeah. And then a lot of this stuff has got, there are parts on here that we don't do. I just found I'm not gonna lie, I just Googled more inverse problems because there's only so many of them you can find. I mean, really, if you think about it, when you have your unit circle, you have 4 quadrantals. And then you have 1, 2, 3 here. So you have 3, 6, 12, 16, 20 of them, right?
3, 6, 9.
Oh, I skipped 12. Or
Skip 9.
Math is hard. 3, 6, 9, 12, and 4 is 16, correct? So there's 16 possible angles, and then you have only 3 trig functions. So there's only, what is that? 48 possible questions to ask.
All I gotta do is memorize all 48.
Oh, that's it. Yeah. And you know,
It's not that bad.
it's not bad. Look, what do you got? No, there's certain parts on here that I want to talk about and go from there and show you different examples. So,
Problems.
all right, I know it's a lot of problems. Oh, I just realized this. I have page 2 first, then page 1. I am awesome. So on page 2, all I'm worried about is 1 through 8. Okay? And I'm going to show you an example with the negative value first. Okay? So let's look at number 6. Okay? Let's look at number 6.
We're 2 or 2? On 2, Mo.
first page.
First page,
Well-
page 2.
Yeah, come on. Who else doesn't start on page 2? I mean, yeah.
Just chunk it, start on page 1. Whatever. You always do page 1 with us. Who's that?
Who needs the introduction? to
There's
anything,
2
right?
right pages. There's one.
This is a book. Read this book. So my sister-in-law's brother wrote a book, and it got published and it's sold on Amazon. It's pretty cool.
Pretty sweet.
That's really cool.
What's it about?
Murder mystery.
Wow.
I believe, I don't know.
$10.
It's hardcover, so whatever that is. 18 bucks, maybe 20 bucks.
Do you have a guy?
No, but I missed the book signing. I know the guy. I played golf with him a bunch of times. He's a real nice guy. He's an optometrist. He wrote a book.
Have you read it?
Do you win
Tom
one?
Church writes a book?
You didn't see that come, did you?
One.
That was awful. All right, so this means the that was so bad. You didn't hear that?
He said, didn't see that one coming.
He's an optometrist, wrote the book.
Got it.
Anyway,
I got
You
it.
know?
thanks. Anyway, so this means the same question as find the cosecant of the angle that has the tangent of -5/12. So when you go to place this out with theta and stuff, in order for tangent to be negative, remember when you're finding the inverse tangent functions, it means you're going to drop to here. Okay? If you place theta, tangent is 1 over what?
Opposite over adjacent.
So which one is my negative?
What?
5. Tangent to be negative, the opposite is negative. And you remember that tangent is opposite over hypotenuse. Or, I'm sorry. And that's twice I've done that. Opposite over adjacent. What's my R value?
I got
5, 12.
Oh,
It's a triple.
I never
That's B.
quite.
Cosecant is the inverse of what trig
Definitely a
function?
B.
Sine.
Sine of this would be -5 over 13, so the cosecant would be
13 over -5.
good.
Why is it negative?
Why is it -5? When you work with arctangent, okay, remember it's what angle has. So it's what angle has that. So tangent, you're going to drop between here and here. Tangent being opposite over hypotenuse, the fraction is opposite hypotenuse. Damn it, it's 3 times adjacent. Opposite adjacent. Excuse me. Well, I can't, I never screw up tangent, and I've screwed it up 3 times. I'm gonna put a quarter in a jar now.
One day.
So-
I think that's worth $1. That's
It's an
definitely
A.
worth
So my opposite would then, for theta being placed at the origin, the opposite would be the -5, the adjacent would be the 12.
$1. I don't understand that concept. Why do people put dollars in a jar? Like, where's that? What's that money going to?
When you need money, you have money in a jar.
It's so simple.
But if it's in the wallet, I'll spend it. But if it's in a jar, I don't see it. And then all of a sudden there's more money in the jar and I can buy Christmas gifts with it. I highly recommend that.
Doesn't that?
Seriously. Or when you guys get, this is a little top tip for today, besides forgetting what tangent is. When you get older, there are times in your lives you might actually have to go to the bank and get cash, because not everybody takes a credit card. So you might actually have to have cash at some times. When you get cash, grab an extra 20 bucks and throw it in a jar. Over time, that 20 bucks grows, and all of a sudden you might have 300 bucks, and you're like, woohoo, we can go buy Christmas gifts, or whatever. Do it all the time. It's a great idea for saving without thinking you're saving. A lazy boy. You want to buy a lazy boy. Exactly. Sir.
These are the same as the ones we were doing before. Those are same front sides.
Yeah.
Triangles.
All right, so on there is just the 1 through 8 stuff. And look, I got it right. The answer's on the bottom.
Oh, they're on the bottom.
So you can always check your work.
That's it.
On the second page, which is page 1. Woo!
Wait, just the back of that one?
Yeah, the back of that one. See, all those are just your arc sign. You signed in what angle has.
It's 19 through 38.
Yeah, it's all kind of the same problem. Okay. What angle has the sine of root 3 over 2? Well, what triangle has the root 3 over 2?
30/60.
The 30/60.
90. You got
Which one of those has the sine 60 degrees? So my answer would be 60 degree or pi over 3. Very good. So I would be able to do 19 through 38. I don't think that should be too much of a hassle. The other ones are just reciprocal. I wouldn't worry about. Don't worry about the ones that are crooked. After that, that page is finito.
Baloney.
Baloney. Balugna.
Do we do 39
What about the last?
Yeah.
I'm getting there.
So we don't have to do it.
You're always ahead of me.
I don't, that's, do we do 39 to 48 then?
No, you don't need to. Because those are they're not bouncing in the quadrant. I couldn't find any extras of those. That's just press a button. That's boring. That next page where it says pre-calc section 4.7, that's all the same problems as the 19 through 38. They're all the same. There's only, you'll probably see some repeats. I would be able to do all of those, because those are easy. And then the back page is when you start spinning stuff around and you're doing some composites again. Those shouldn't be bad. I mean, it's just the first 9 of those. So the very last page, so page 3, I would be able to do all. Page 4, I would do 21 through 29. Now, we've done the ones of the sine of the arc cosine. Sounds like in Raiders if you watch the arc thing. We've done the sine of the arc cosine, but what would be the arc cosine, or the arc tangent of cosine? Take a look at 29. So this says, what angle has the tangent of cosine of pi? Well, work inside out. What's the cosine of pi?
-1.
-1. Very good. So that means tangent, what angle has a tangent of -1? Very good. No.
No.
-45. Or pi over. Okay. You're just working backwards. Okay? Just working for the other way. It's a composite function. It's a composite function. It's made up of 2 functions made up of one another. So I would be able to do those. Like I said, the only other style that's not on here that I was searching around for was more of these. I just can't find any more. Okay? And those, if you remember, all you're doing is hitting the buttons on the calculator and getting the reference angle and then bouncing it into whatever quadrant they're asking you to bounce it into. Okay. Remember, reference angles are always bounced off of the x-axis. I think most of you guys have done a pretty good job of remembering that. I haven't seen too many people accidentally going off the y. It happens from time to time, but just remember, everything's always off of the x. Yeah.
So this tomorrow's just like off of the spreadsheet and then we're going to get last name.
Yeah, don't forget, we still have angle of elevation, depression. Those were problems that we looked at that we used calculators for. Areas of sector, arc length were calculator stuff. Very simple, the word problems that were very simple stuff, like that, how you did some tangent things with elevations and junk. And then obviously this stuff that we're looking at today would basically be all the non-calculator, really. Okay. What's that? It is 2-part. Calculator, non-calculator. Just for refresher, do you guys remember the difference between angle of elevation? That's pretty much it.
Seems easy enough.
Angle of elevation versus angle of depression. Angle of elevation is line of sight up, and this is line of sight down.
There's gonna be more problems tomorrow, right?
Okay.
Okay.
So if you've got angle of elevation versus angle of depression, you have your line of sight looking up. Your line of sight is always parallel to what? The ground. Very good. line of sight is always parallel to ground. The distances that we can measure are always going to be the distances you can put a tape measure on. Can you measure diagonal distances with a tape measure with accuracy after about 2-3 feet? Nope. Because if you're fishing a tape measure out, what happens to tape measure? It falls over. Okay? So that's why we always measure horizontal, or you hook it and you can drop the tape measure down vertically. So remember that. Yes. One of the tricks with angle of depression is this angle here, which means it's the angle of elevation here. That's one of the tricks of the angle of depression. That's what most people forget. Okay? Because these two lines are parallel, and you have two parallel lines cut by a transversal. So your line of sight down is the same thing as if you were on the ground looking up. Yeah, no.
So those two angles are
Congruent, yeah. Yep. So if your angle of depression is 35 degrees, that's your line of sight looking down. Well, that's the same thing if I was down there looking up. You just spin to the other and inside. You want to spin to get into the triangle.
Okay.
Whereas angle of elevation, it just means you're here looking up to something, and that's your elevation.
It's easy enough.
Yeah, and sometimes, if you guys remember that when you guys did the clinometer thing with Sev last year, where you might sometimes have to add in a height for your eyesight. It just depends on the problem. It's not a really complicated scenario. It's a lot of tangents, really. What else is there? What am I forgetting? What are you forgetting?
Oh, no, I don't even know.
How long is it?
It's like 3 pages. But I give you space to draw
Does
pictures
this go in
and
the
stuff.
quiz? Does this go in the
That'll be
quiz
a test.
or the test?
Oh, it does. Yes.
Why is it called a
Yes,
cross
ma'am. Sorry.
section then?
I'm looking at him still.
Wait, is this?
We are not to do law of science.
No. We'll save that for the final.
Sweet.
Wait, so we don't
No.
So is it more calculator or non-calculator problems?
Yes.
know. Do we get dumb
Which one
calculator?
is it more?
Oh.
So like half and half? All right.
Do we get dumb calculators?
No. If you had a dumb waiter, that'd be pretty cool. You can get up and down the stairs a lot faster. A dumb waiter is a small elevator in a house. In case
I used to have it in my house. We took it out because I liked
Did you what?
it.
we had a laundry chute in our house growing up too. We threw a lot of stuff down that thing.
Oh yeah. I got lunch in my house. I know what it
It was always funny when somebody came home. When my brother and I were younger, when my dad or my mom would come home, we'd drop like G.I. Joe guys with parachutes on them. It's pretty awesome. Transformers, water balloons, whatever. Confetti. It's good.
Confetti.
What else you got? Now's your time. I got time.
I
I
got
got nothing else to do.
nothing.
We can't go home.
What about 26 on this?
26. The arc cosine of the sine of pi over 3.
26.
Is this the right one?
Yeah.
Okay. Oh, pi over 3. That's our what angle? 60. So what is the sine of 60? So what angle has a cosine of root 3 over 2? 30. Or? All right. Yes? I'll have that on there, yeah. I'll say, for some of those, it'll say, put your answer in both radians or degrees. But then if it says just evaluate, like, the ones where we had yesterday. What is the cosine of 17 or 16 pi over 3? You're just going to give me that order, cosine value, whatever. When you spin it, it's going to be that number. And there is no extra, there's no radian, there's no degree. It's just, it's 1/2. It's root 3 over 2. It's 6. Not 6, but you know. So, all right. Here, Cole, you have 2 more today. I almost threw it, but I'm like, I'm gonna drop everything out. Paper said it was close for after towards
It
the end.
was. Oh, I gotta go again.
Who do you guys get next?
The winner of Jacobs and Larkin tonight.
Where will that be at?
South Elgin. I didn't look at the TV or whatever.
At least you knew how to spell your name. I forget who it was last year who couldn't spell their name. What else we got? Anything good?
I get the call on the TV.
We'll start solving the equations on Friday then. And I've shown you guys that. You remember how we did like 2 cosine x minus 1 equals 0?
Yeah.
Oh, yeah.
We'll start that stuff on Friday. We'll do that for probably Friday, Monday, Tuesday. And then maybe switch it up and do all the simplify, verify problems before we do the graphing, and do graphing last. Simplify, verify is fun.